Yeah,
Morning,
so
morning.
we have everything set for you, and yeah, your show time. Thank you.
Okay. So thank you. Good morning, everyone. It's 10 o'clock in the morning. So I would like to introduce the topic of towards private on-chain algorithmic trading. So it's for my latest academic piece or research summary for Smart Contract Research Forum. And it's authored by Arthur Jervis, Ben Lifshitz, and Saren Kokugler. So before that, just a little bit about myself. So the fool is the precursor to the savior. So just a brief abstract of how I actually got to this point, and to share my research summary today. So I'm actually a researcher for Smart Contract Research Forum. It's a online forum that tries to promote blockchain research and connect academia with industry. And I'm currently also the Google Developer Student Club lead for Tamkang University. And privately, I also do a lot of data science research with a PhD in statistics in New York. So for that, for that part, I currently am trying to publish 2 pieces of primary research, but that's irrelevant for the time being. And I'm also a computer science and information engineering student at Tamkang University. So yes, for just to let you know, I'm not the author of this research, and I'm only responsible to promote, to do the research summary for the forum and hopefully get some novelty and discussions on the forum. So yes. So yeah, as I said, SCURF is a forum for trying to connect academia with industry. So before I move on, I also want to, like, my main interests are in data science. The reason why I got into doing maybe academic journals for this forum was because I had an internship this summer working as an analytics engineer for a blockchain startup. And it seemed to me that data science and blockchain itself was very contradicting in nature, where data science requires a large data pool of centralized data that would privilege the platforms that collect such data, and blockchain as a distributed ledger or database, not really database, distributed ledger, tries to decentralize and allow privileges for individual users or participants on the blockchain. So that to me was sort of a very interesting topic to get into, how to integrate data science and blockchain technology. And that's why I'm here. So SCURF, yes, just to repeat, our mission is to connect academia and industry. Our content is designed to create long-tailed conversation between the two. So towards private on-chain algorithmic trading. So just a general abstract first. This paper introduces partitioning of algorithmic computation into on-off chain components, which provides a measure of end-to-end integrity while preserving algorithmic parameters. And it's Chainbot. So just some stats. So the performance of Chainbot as the arbitrage bot. So what is an arbitrage bot? It's basically a bot that tries to make transactions on the market or stock market that would try to gain the most returns. So there are actually other discussion forums on SCURF, on the Smart Contract Research Forum, coding a DeFi arbitration bot, or Flash Boys, where they talk about some things about gas prices. I'll explain more about gas prices later. So yes, Chainbot tries to introduce more machine learning algorithms. In this case, they try to utilize the Bollinger Band algorithm into the blockchain network as an arbitration bot. So it returns a 2.4 times using the average return moving average index against the buy and hold strategy, and returns 1.4 times using the Sharpe ratio against the buy and hold strategy. So, but the buy and hold strategy is basically just buying a stock and having it there and see if there's any returns. So, in that sense, Chainbot does make quite a bit of returns. Across 1,000 runs, Chainbot was able to, each execution takes 48 seconds. That is actually acceptable in the sense that there are actually the less frequent execution lowers the gas prices, and it creates a larger standard deviation for the Chainbot to make returns from. Yes. So the core research question towards on-chain, private on-chain algorithmic trading. So what is the possible architectural design for an on-chain, off-chain hybrid to develop a trading algorithm that is trust minimized, transparent, yet able to execute without having to lose its competitive advantage due to privacy loss? Just to highlight some notes, if everything is on-chain, everything is sort of public and permissionless and trustless. And if your own algorithm is also on-chain, then there are competitive disadvantages because you're practically sharing your entire algorithm out. So I'll get more to that later. So just some background information. So when we talk about blockchain, there is also the discussion or the topic of what is gas. So gas is just the smallest type of work in the process on the Ethereum network. So it's just a unit, smallest unit for measuring the computation required or computation equivalent required to make transactions on the blockchain. So yes, I mentioned about blockchain, the permissionless or trustless nature of blockchain. To that sense, is not entirely trustless. Even though it tries to be anonymous, it still has its limits. So according to the Bitcoin white paper, privacy can still be maintained by breaking the flow of information in another place. By keeping public keys anonymous, the public can see that someone is sending an amount to someone else, but without information linking the transaction to anyone. Some linking is still unavoidable with multi-input transactions, which necessarily reveal that their inputs were owned by the same owner. The risk is that if the owner of the key is revealed, linking could reveal other transactions that belong to the same owner. Yes, so blockchain in itself is not entirely anonymous. It's technically more pseudo-anonymous. Yes, so this introduces the idea that all peer-to-peer interactions on non-private blockchain may be captured and used to undermine the user privacy. So another issue with blockchain, which also really interests me individually with how like the convergence or integration, trying to integrate data science and blockchain technology, is that blockchain itself is actually a very new technology in the sense that it has its own issues written all over the place. Not really all over the place, but you can never, there are three main issues. It's scalability, decentralization, and security. And you can never actually have two of those components at the same time. So blockchain being a decentralized ledger or a decentralized data network, in essence. So it tries to be decentralized but the more decentralized it is, the slower the transaction speed is on the network. And if you try to, say, you centralize it a bit more and make it less centralized, which is sort of opposing to the inception of what blockchain is, it increases the security, because if it's more centralized, you can add more layers of abstraction to that more centralized network. But as I said, it would decrease the decentralization component. And if you try to increase scalability, both decentralization and security would suffer. So that's the general gist of the issues currently facing blockchain and why it's not that widely adopted as for now. So to tackle some of the scaling trilemma, this paper tries to utilize the layer 2 protocol on top of the layer 1 protocol of blockchains. The layer 1 protocol being permissionless and public blockchain in its inception, purest form. The layer 2 tries to utilize more off-chain technologies and to perform less proof of work and less, say, on-chain transactions, so then more off-chain computation can take place and less proof of work can take place, but still utilizing, like they call it the zero knowledge proof, that can prove the general abstract of the blockchain network without actually going through every single transaction and proving every single transaction to work. So, as I said, blockchain and data science is actually quite opposing in nature, but there was actually quite a bit of literature that would depict machine learning to, say, predict Bitcoin prices, or some adversarial networks, adversarial neural networks that can, or more like, it's graph neural networks that work utilizing the blockchain network. So just general past literature here. And so what is the Bollinger Band? It's really just bands that depicts the highs and lows relative to the current place of where the current price of the stock is. So it aids in the rigorous pattern recognition and is useful in comparing price movements to the movement of indicators that arrived to the transaction decision. So yes, I'll now start explaining a bit about the Chainbot architecture in abstract. So basically, Chainbot has, well, 3 to 4 components. The first component is where it does the data collection and the aggregation of basic heuristics on-chain, where it tries to access a data oracle. So what an oracle is really just a graph compilation of data, where in each of the nodes within the graph would have its corresponding category related to the data. So it tries to collect from the oracle, and then it aggregates and collects the data, and that's where the off-chain bot comes into play. It tries to request to the on-chain bot the public parameters or the collected data or heuristics, and then it performs its trading algorithm on the spot and parameterizes the trading algorithm, and then decides to execute the trade. So the actual execution of the trade is actually back on chain. So first comes the proof of the system, the layer 2 protocol, which they utilize the zero knowledge proof. So as in where zero knowledge proof, as in you don't actually need the intrinsic data point or the architecture to prove that a decision made somewhere else is accurate or not. So there's actually no connection between the off-chain bot and the on-chain execution. So that's why the zero knowledge proof aspect is has its own importance. Yes, and then there's, as I said, the on-chain oracle. So back on chain, it would, after going through the zero knowledge proof and the L2 protocol for validation for the decentralized exchange, it would then execute its trading arbitrage. So yes, if you were listening to me just now, there would probably be some trust assumptions of this Chainbot. So there are actually 6 trust assumptions. The first one is that the Chainbot currently completely ignores the updates and ramifications of the blockchain source code itself. So, and it also assumes that all the participants within the network are honest and no like selfish mining or some sort of deviation from the concept of blockchain, the trustlessness of blockchain, or people malicious enough to take advantage of that trustlessness is there. The second one is that there is, for these zero knowledge proof, they utilize a generation ceremony based off a multi-party computation. The significance of that is that it's not blockchain. This generation ceremony. One of the ways to fix this validation issue is to utilize the buzzword, the decentralized autonomous organizations. So in that sense, you would have to provide the data to that committee. And that would sort of infringe upon the trustlessness of blockchain. So yes, you have to trust that the multi-party computation and the generation ceremony, yes, you have to trust it. Trust, so sort of against the trustlessness of that. So there's also the off-chain bot fund integrity. So there's, once you're off-chain, the trustlessness and the integrity assumption is no longer there. So as I said, it tries to utilize the zero knowledge proof from off-chain to on-chain, but yeah, the blockchain nature for trustlessness does not include off-chain bots. So the fourth one is the decentralized exchange integrity. So it assumes that privacy-enhancing DEXs enables ensuring trades correctly executed on verified financial decisions. The fifth one, DEX privacy. And it also assumes that the decentralized exchange, the network does not reveal the data type of the incumbent data from the oracle, such as asset pairs, sources, destinations, etc. And it also assumes that the data from the oracle itself is the correct and the accurate data that it's trying to aggregate and parameterize. So now we can get to the performance of the summary. So yes, performed on a local machine, 2-core Intel. I won't get to that. Yes, on average, it takes 49 seconds, 48.4 seconds end-to-end per transaction per arbitrage. And it takes around 473,402 gas units per end-to-end execution. But the frequency of execution does not affect the rate of return. As I said, the less frequent the transaction or arbitrage takes place, the more standard deviation off of the mean of the current price point. So, and it also lowers the gas price. So there's actually potential for larger returns in conjunction with lowering the gas price, the processing computation required for each transaction. So, well, my picture is sort of obstructing some of the slides, but time measurements. as I said, in total it takes 48.4 seconds. The actual off-chain running of the algorithm just takes 0.2 to 0.8 seconds. The two components that take the longest is actually the on-chain data collection and aggregation of heuristics, and the verification of the zero knowledge proof from off-chain to back on-chain. So which the first one, the data collection, takes 22.8 seconds. The zero knowledge proof, the validation of the off-chain to off-chain, the validation takes 23 seconds. So this is actually a common issue for blockchain as well. I would like to mention that even for Bitcoin, the public Bitcoin network, it takes, for each second, there's only 7 transactions possible, wherein compared to like Visa, the platform, there's like 50,000 transactions per second. So as I mentioned, there's also the scalability trilemma that's still needed to be fixed for blockchain. Yes, and the actual execution of the arbitrage just takes 2.3 seconds. So that's the general gist. The machine learning components of this Chainbot, this is actually the non-issue. It only takes like 0.2 to 0.8 seconds. Granted that it's only like a Bollinger Band trading algorithm, which is really just the heuristical based analysis and decision making. So yeah, the gas costs. So here are more stats about gas. I actually haven't read too much about the requirements, or should I say the criteria of what consists of high volume of gas or low volume of gas, since my initial interest into getting into this research work was my previous work with a startup company as their analytics engineer, trying to come up with some data science solutions for their blockchain platform. So, but here are the general stats. The average gas cost of end-to-end execution is around 0.04459 Ethereum, which is 150 USD as of 2021. August 28. So some implications and follow-ups. The first gauging implication is that within the time frame of 49 seconds, the actual parameters, the actual decision made by the off-chain bot, which is parameterized 49 seconds ago, upon execution, it might be making an execution wherein the price has already changed. So the actual parameterization of the decision made by the bot may not be applicable. And there's also the off-chain integrity concerns, where it's actually very difficult to verify the decisions of the off-chain bot. So alternatives, as I said, there's DAOs or DACs, the decentralized autonomous organizations, but then there's also trade-off where you have to give the information to the DAO or DAC. And because the entirety of the Chainbots utilizes many programming languages, it creates a hard to maintain and fragile deployment process. So creating a program that can transpile and compile to many different languages would improve upon the implementation of this Chainbot. So just to recap, the key discussion takeaways, it tries to present a system of automating trading on blockchain. It minimizes trust, no going public with trade algorithm, and uses zero knowledge proofs for end-to-end integrity and private decentralized exchanges. So, well, there's lots of different applications, but here I'm introducing a hybrid and on-chain, off-chain approach that may in the future be the starting point for many different other on-chain, off-chain integrations between data science and blockchain. So just some closing notes. So as an anecdote, in this paper, it says, in our implementation, an average user willing to invest $1,000 with Chainbot would earn $105 while spending $3 in gas. So this is the citation for the Towards Private On-Chain Algorithmic Trading. And the first author is Siren Kokeler, and she is a PhD student from the University of Cambridge with a Cambridge Trust and King's College Scholarship. And this is Arthur Jarvis. His research focuses on the security and privacy financial aspects of decentralized technology. Here's the QR code to his website. So if you guys are interested, you can scan the QR code. The third author is Ben Lifshitz. He is the CEO of Zilliqa. Yes, I hope I pronounced that right. And that's the QR code to a blog post about his contributions to Zilliqa. And fine, well, just to snoop my way in, I'm currently the GDSC TKU lead. Here we have a YouTube channel and Discord, and that's my LinkedIn. But here's the QR code to the actual forum post itself on Smart Contract Research Forum. So if you guys are interested, you can scan the QR code, and if there's any points I missed or any questions, you can try to post it on there, and I'll start this novel discussion with you. Thank you very much. That's all from me. I'll keep the QR code up just in case anyone's interested to scan. But yes, hello. Any questions from the audience? Should I just leave studio? That is awkward. Pardon, I can't hear you.
Okay, fantastic. Okay.
I hear you.
Thanks for the presentation.
No problem. Thank you for allowing me in for the presentation.
Hello, Tony. Thanks a lot for the sharing. I'm just curious, if we were to understand more, what would be your advice to the new joiners to your topic? Can you share some of the experience or the difficulties that you have encountered?
So, for me, since I'm actually quite new to data science, the blockchain domain itself, during the process of trying to create this academic journal on the Smart Contract Research Forum, I had to read up on a lot of initial other references on the paper. For example, the Bitcoin white paper, and also say the coding arbitration bot DeFi on the blockchain. All these different papers on the forum or actual primary source papers to understand what's happening in the background. But I would really recommend newcomers to actually go on the Smart Contract Research Forum and maybe browse through some of their research summaries. They try their best to make the research today's research blockchain accessible to try to connect academia with industry. So yes, please go on, scan the QR code, and then maybe ask some questions, and I'll try to reply you there.
Great, thank you, Tony. Sorry, I'm just checking if there are any other comments from the floor. Anyone?
Sorry if I babbled too much details.
No, it's good. Yeah, if no, then thanks, Tony, and then we'll see everyone again at 10:45. Thank you. See you, Tony.
Thank you. See you. Bye-bye.